Hey everyone, good morning. I'm Pranshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is max sum of a pair with equal sum of digits. Okay, so let's see what is this question and how we can solve it. So in this question, you are given a zero indexed array nums consisting of positive integers, and you can choose two indices I and j such that I is not equals to j, and the sum of digits of the number nums I is equal to that of nums j, and you need to return the maximum value of nums I plus nums j that you can obtain over all possible indices I and j that satisfy the conditions. And what are the conditions? That the sum of digits of number I should be equals to number of j. Okay, so let's see. You have been given with this nums vector. Let's say if we pre-calculate the sum of all the digits, like its sum is 9, it's 7, then 9, then 4, and then 7. And you need to maximize the sum of nums of I plus nums of j. Okay, so here 9 and 9, 18 and 36 have digit sum as 9, and 43 and 7 have digit sum as 9, and you need to find the maximum of them, that is 54, which is 18 plus 36. Okay, let's see another example. So its sum is 1, it's 3, it's 10, and it's 5. So no two numbers have equal digit sum. That's why we will simply return -1 if no two numbers have equal digit sum. Okay, so very first brute force approach which comes into our mind, that we can just keep the track of the sum of digits, right, in another vector, let's say, and we can iterate in our nums with two pointers, let's say I and j. For every pointer we can check, oh yes, if their sum are equal, no, their sum are not equal, move forward. Oh yes, their sum are equal, if their sum are equal, then just maximize the sum at every step. So as we are using two pointers here, it means nested loop, right? So its time complexity will become big O of n square, as we are doing a nested loop iteration. And for the complexity of calculating the sum of digits, it may be big O of 10 up to, because our nums of I can be up to 10 ki power 9. So we just need to do the sum of all the digits. So it may be big O of 10, which can be described as a constant. So its time complexity will be big O of n square. Okay, so let's see the constraints. And the nums of length can be up to 10 ki power 5. Okay, so this can go up to 10 ki power 10, which will give TL. So this is not going to work. Okay, so let's see, can we do this in some better time complexity? Okay, so let's say you have been given with this array nums, in which this digit has some 9, this has some 9, this nums has some 9. Okay, and this has some 7, this has some 7, and this has some 7. And we have nothing to do with 4, as no other nums has digit sum as 4. Okay, so what we need to do is we need to get the maximum of this, right, maximum sum of this and maximum sum of this, right, and then maximize them, right? Okay, so can you see here, like we need to keep the track of the digit sum and the corresponding number which has the digit sum as 9. Okay, so can we create like this, something like this? 9, the numbers whose sum is 9 are 18, 36, 81, right? And the numbers whose digit sum is 7 are 43, 34, and 7, and 4 is 13. Okay, so can you see that we have created a map? Okay, so we can simply create a digit map, right, digit sum map, which will store the digit sum and its corresponding numbers which have that digit sum. Okay, and then what we need to do, we need to either sort it or we can insert them in a priority queue. right? Why? Because we need the top two maximum elements, because we need to maximize. Let's say we have two numbers and we need to get the maximum value, so obviously we will need to maximize these two numbers. So to get the maximum or top two numbers, either we can sort this vector or whatever we are using, or we can create it as a priority queue so that we can get the top two maximum elements. Okay, so time complexity of this approach will be big O of n for the iterating in this map, right, and big O of log n for sorting, let's say. Or if we store in a priority queue, then it's still big O log n, because priority queue's push operation complexity is log n, right? And its space complexity will also be big O of n, as we have used this map for storing all the numbers, right? Okay, so let's see its code once. So here we have created an unordered map of integer comma priority queue, and then we have started iterating in the nums for calculating the sum of digits, right? So in this way, by dividing it by 10, we can calculate the digit sum. Let's say 63 when we divide it by 10. So the modulo will give us 63, modulo will give us 3 plus, and then nums will become 6, and then 6 modulo 10 will give us 6. So finally we will get 9 as digit sum, and we will simply store that digit sum in our priority queue. Okay, and then we will start iterating on our map. If the priority queue size is greater than or equals to 2, only then we can get the top two elements, top two maximum elements. So we will pop out the first element and then the second element, and then store the maximum of maxsum comma element 1 plus element 2, right? Okay, but yeah, this complexity will work. This will not give you TLE, because this is 10 to the power 5 log 10 to the power 5. It will going to work. But can we do it in a little better complexity? Okay, let's see. So instead of storing all the numbers, let's say instead of storing all the numbers, can we just store a single number and will it work? Okay, let's see how. Let me just clear this. Yeah. So we will keep track of max sum. Okay. So let's say we are at 9 right now. Digit sum as 9. Oh, 9. 9 doesn't exist in our map. Okay, we can simply update it with 18. Okay. And then 7. Oh, 7 also doesn't exist in our map till now. So we will update it with 43. Now this map is of int comma end. Oh, then we are again at 9. Oh, 9 already exists in our map with 18. Okay, so now the current value is 36. Okay, so we can update our max sum with maximum of max sum comma 18 plus 36, which will become 54, right? Okay, and we'll update our map with maximum of 18 comma 36. Now it will become 36. Okay, now we are again at 9, 81. Oh, 9 already exists in our map. Okay, now we will update our max sum with 36 plus 81. The value which is stored in the map is maximum till now, and we again encountered a value. So we will update our max sum with maximum of 36 plus 81, that is 7, 8, 3, 11. Now it will be updated with 117. Okay. Now we will also update the map with maximum of 36, 81. Okay, now it will become 81. Now we are at 4. Oh, 4 doesn't exist in the map. Let's update it. Now we are at 7. Oh, 7 already exists in our map. Let's update our maximum, that is 43 plus 34, which is 77. No, 117 is already greater than 77. So let's keep it as 117. And then we will update our digit map with maximum of 43 and 34. 43 is maximum, so it's fine. Now we are again at 7. Oh, 7 already exists in our map. Okay, so we will again update our maximum with maximum of 43 plus 7, that is 50, but it has already been updated with 117. So let's keep it as is. And again update our digit map with maximum of 43,7. Oh, 43 is maximum. So okay, no worries. So in this way, we will be saving the complexity of that sort operation or that priority queue operation. If we store the maximum number till now and then keep updating our maximum in that iteration only, so this way we done in big O of n complexity and space complexity of big O of 1. I will tell you how, but first let's see its code. Okay, so in this we have created a digit sum map with max sum initialized with -1, and then we have simply calculated the digit sum. Okay, and then check if that digit sum already exists in the map, then we will simply update it with digit sum plus nums of I and then update our map, right? So its time complexity will be big O of n as we are doing a single iteration only, and its space complexity will be like we have created this map, and it will store the sum of digits, right? That digits can vary up to 1 to 10 ki power 9, as you can see in the constraints, 1 to 10 ki power 9, right? Okay, so 10 ki power 9 can be written as 9 times 9. Okay, so 9 nines are 81. So the sum can vary up to 1 to 81. So that is big O of 81, or we can say it as big O of 1. So the time complexity is big O of n and space complexity is big O of 1. So this is the most optimized approach for this question. So yeah, this was all for this question. I hope you get it. But if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.